Um, how many people in the room are own? How many people in the room own a drone? Nice. How many people in the room flew a drone before? Okay, so we have quite a batch of people that actually played with it for a while. So I'm just going to give you like a really short bio. Like Rick said, I've been flying RC stuff and later on drones since I was 8. It's a hobby of mine. It's a passion of mine that I later turned into my profession. As of now, I'm working in Hydrix. It's a company based in Melbourne. We do safety critical and mission critical products, which means mechanics, software, hardware, for rail, defense, aerospace, and medical devices. Anything from heart pumps to things that go up in the air. As you can see, as you can probably hear, I'm not exactly from North Scotland. I'm from a really nice, calm, peaceful place in the Middle East that you don't hear a lot on the news called Israel. Israel is the biggest exporter of UAVs, military UAVs, roughly 60–70% as of like 2015. And surprisingly or not, the Australian Air Force chose AI drones, which are made in Israel. Probably the best drones in the world, in my opinion. And I might be a bit bribed because I used to work there. I worked over there in AI for 4 years. AI stands for Israel Aerospace Industries. I reckon if this is the bar of 60% of all the drones that is being sold in the world, this is probably the chunk of AI, and the rest is Elbit. I used to work over there in the avionics department. Avionics is not aeronautic. Aeronautical department in a way is in charge of the airframe itself, the shape, the aerodynamics of the plane. Avionics is everything that runs inside the plane, from servos, actuators, payloads, autopilot, navigation system, inertial measuring unit, everything that makes the plane fly that is not physical. Software, hardware, electro-optics, and anything in between. In a way, when we think of drones, this is probably the picture that most of us have in our heads. Yeah, that's probably for rotors, multirotor, but not every drone looks like that. Some of the drones might look like that, which basically this is a fixed wing flying drone with a payload, a camera, telemetry, video link, and some maybe other capabilities. Others might look like that, which is the US Reaper that most of you probably know when you think of military drone. This is probably the picture that you have in your head. Or maybe something that looked like a helicopter without a pilot. Or something like urban aeronautics, which is supposed to be autonomous flying ambulance that can, in a way, touch buildings when it evacuates people, or landing in the middle of the battlefield without actually putting in risk human lives. Or even something more exotic, like an airplane with 5 propellers that has VTOL capability. VTOL stands for vertical takeoff landing. And it can actually go forward. So you actually can hover and fly forward. And you can go even more exotic, like this French company that built a Coaxial Drones, which it means that you have 2 rotors counter-rotating. It's basically 2 helicopters stacked on each other. So why do we have all those configurations? Why do we have all those types? The answer is basically, what is the end game? What are we trying to achieve? What is our mission? What are those things designed to do? Because drone on its own does nothing. Maybe it's fun, maybe photography, but in a way it's just a mean to an end. You want to achieve something, either if it's reconnaissance, if it's maybe protection, maybe just taking some footage. So, yay, we're Rick and Morty fans. Yay, 4 more days. They released season 3. So when we think of, okay, I have a drone, what is the purpose of the drone? What am I trying to achieve? Some of the things might think of, okay, what is my mission? What is the flight time that I need? What is the speed that I have to travel in? What is the duration over the objective? What is the ground support that I need? What of comms do I need? Communication lines? What of weather that I have? Maybe other constraint, visibility, radar signatures. Every one of those things is something that takes into account in the equation of, okay, now I have to design some kind of drone. I don't know if it's going to be a multirotor, heli-based, coaxial, fixed wing, not fixed winged. Is it going to have to need a runway? Is it going to just fire through a catapult? Is it going to have a parachute landing? Is it going to have a runway landing? All those things you're supposed to take into account when you choose your solution to solve certain problem. It could be military one, it could be taking footage of a real estate property, it could be mining, it could be a million things. This is a company that is based, if I'm not mistaken, in Gippsland, and they design target UAVs. It's basically just a really fancy and really nice RC airplane that probably could fly on using just RC, radio control, like the one that I have here. This is probably how they test their first ones. And it uses for target practicing, for jet fighters, for radar signatures, speed testing, smoke, whatever you can think of. It's a very expensive target. So if we talked on the previous slide about all the different things in a way that we're thinking when you take into account the mission, duration, target of the duration over the objective, etc., etc. In a way, we can classify the 4 types of drones that we're probably going to look at into those 5 things. Passenger flights or deliveries, surveying and reconnaissance, and there is slight difference between the two. We'll talk about it in a minute. Defense and search and rescue. You probably cannot see it because of that poster, but yeah. Yeah, no worries. Yep. This is another example of another drone. It's from an Israeli company called Raphael. It's actually a coaxial flying camera. That's it. It's something that's supposed to be on soldiers' backpack or something like just like threw it up in the air. It opens and it starts like flying and rotating and hovering around, and you can control it. Another product, this comes from where I used to work in IAI. Forgot the name that it was published as internationally. BAT. It's a Tetris Multirotor. As you can see here, we have the classic four rotor. We have a cable here that supplies electricity. This thing carries no battery at all, and it could hover for example, border protection, over ships, if you want to see above what the bridge or the highest point of the ship can see. And in a way, just think of it as flying camera with an infinite amount of time. Something that if we now think of multirotors of drones, that doesn't work because you have to land every 20 minutes, 2 hours to change batteries. You have to do some maintenance. This thing in a way can fly indefinitely. Another example is if I am a soldier in the battlefield and I just want to see what's happening over the hill, that kind of solution called over-the-hill intelligence. I might fly something that looks like a pipe with 2 fancy wings. I'll have a screen here, and I might have between 5 and 15 minutes of video of what's happening in front of me, and I can actually decide and maybe redesign the whole base, what I'm going to do, or whatever. Another kind of drone could be even a blimp, just like a flying zeppelin. The one that you sometimes see on the stadiums here in Australia, in Hisense, for example, on concerts, or when you see like netball shows, something like that. You have a helium balloon. You have over here a payload. Sometimes you have motors. Sometimes it's tethered with wire to a base station. And you can actually get quite coverage with that kind of system. You can probably get from 150 meters, 8 kilometers of coverage. So if you're surveying, for example, a mining site, that could be a nice solution. If you want to put it on top of a concert event to secure or just in a way crowd control, that's another option. Yeah. So in a way, if we could classify our mission into 4 or 5 bullets, we can classify our platforms into a couple of types of platform, but it's not exactly clear-cut because some of them are hybrid. Some of them can do a couple of things. The main one are multirotors, what you think of today when you hear about drones, probably the DJI white ones that are quite good actually, very good. Fixed wing. Fixed wing could be the RQ, the Hunter that we saw before on the bottom left side, the fixed wing that we saw. And those fixed wing are usually classified by the duration, the distance to target, if I need airstrips, if I'm going to parachute them, pyrotechnics, and fairy dust that we're going to talk about what exactly is fairy dust that help us sometimes landing and sometimes departing, taking off. Another kind of drones is the just helis, like helicopter that you can see every day in Melbourne, something that helps you sometimes see the traffic. Hybrids, which I sometimes call them ducks. Ducks is a creature that cannot fly well, cannot run well, cannot swim well, but it's alive and it does what it does, quacking. And when we're gonna talk later about trade-offs and what exactly does it mean, for example, when we combine a couple of those configurations, airframes. A nice example for that is the Panther. It's a UAV that, as you can see here, you cannot see here because of the resolution of the projector. It has 3 motors, 1, 2, 3. It can do vertical takeoff and landing, and then it could fly to relatively long distance from its takeoff and landing point. That kind of advantage is usually not something that goes without saying, because in order to achieve takeoff, you might have to have runway, you might have to land afterwards. And this is a very good solution for just like VTOL. But the thing, it usually comes with a price. The price that it comes with is the fact that most of the energy consumption of the whole mission is being spent on taking off and landing. Let's talk about a bit about fairy dust, and let's hope that the Australian internet will work now. Until it will connect, hopefully. So, for example, if you would like to launch a UAV without a runway, this is probably the solution that you would use. What it means that we have a UAV, which we don't have to have any runway for it. Just gonna swap back. But it means that it also doesn't have any wheels. So could you think how it's supposed to land? Maybe it doesn't land. Maybe it's only one way, so you only have to have half of the battery. That's also a valid solution. Just a minute. It's kind of funny angle. Oh, sorry about that. And this is how this UAV lands. With the Australian flag at the top. This kind of solution is very creative, but it doesn't come free. It means that the whole airframe, the whole wings, the fuselage, everything has to be reinforced in order to, in a way, absorb this kind of landing. The intensity of the shock that the whole airframe is absorbing and experiencing while landing, while hanging into that cord is something that is quite dramatic to most of the UAVs. It's like fishing, yeah, in a way. So now that I have my UAV and I know for how long it's supposed to be there, what it's supposed to do, if it's supposed to go back, how it's supposed to land, and a million other considerations, let's talk about payloads. Payloads is what the UAV is supposed to do, or in a way, how the UAV is supposed to do what it's supposed to do over the objective. It could be a day-night camera. It could have stereoscopic vision in order to achieve 3D. It could be using hyperspectral cameras or multispectral cameras. I'm going to tell a funny anecdote about that. If you look on minefields from above, from a drone, when you use hyperspectral cameras, you can see leakage of explosive from the mines around the mines themselves. So if you want to clear a minefield that has been sitting there for 10, 15, 20 years, what you can do is fly the drone with a hyperspectral camera. You'll see nice clouds around the places that you're probably going to find nasty stuff in there, and you can remove them. This is what you will do if you're going to work in the defense world on it. I was in the army for 9 years. I was an officer. And now I work in a medical device. In the medical device, you can use for the exact same technology to classify cannabis plants, flowers, in order to treat people. For example, because flowers are not homogeneous thing, the content of THC and CBD that you get just by taking a picture of the flower using hyperspectral camera, you might see high percentage of CBD or THC, and those could treated like those two chemicals could treat two different kind of people. If you have, for example, a person that suffers from PTSD, post-traumatic distress syndrome, or a kid with epilepsy or ADHD, they might have completely different two treatments, and that kind of thing is a funny example of how the military and the medical world is almost the same. Just a funny anecdote of a project that I used to work with. Radiation sensors. You have USV, for example, what happened in Fukushima a couple of years ago. No one is actually going there anymore. So if you want to monitor the level of radiations, what you could probably will do is chuck a payload on UAV with radiation sensor and see what's happening over there and see if is it safe, how much time can a person stay there without being exposed to lethal radiation. Same thing goes for biological sniffers. If I want to know if certain place has been attacked with some kind of biological warfare, if I want to know if I'm exposed to some kind of bacteria. Obviously, radars, BTS, it stands for base stations for cellular. Just imagine cellular tower, but instead of having the coverage that you have around stationary tower, you'll have it airborne. A nice thing that could be that it's, I don't know, like in a way, it's fantasy of mine that I'll do it here at some point. In 2009, there was a huge fire here, and 180 people died, if I'm not mistaken. Black Saturday in Victoria. One thing that could be done is chuck a BTS on a drone, and the first thing that goes down if you have an earthquake or natural disaster or fire or something like that, the comms, all the communication drops off. If you have a BTS station on a drone, you can actually pinpoint to all the people that holding cell phone in their hands. So you know exactly how many people you have to maybe rescue and exactly from where. Another thing is LiDAR. LiDAR stands for laser radar. We're going to see a slide on it. You might want to use it to put down fires using chemicals or water. You might want to transport humans with it, just like human transportation in a way like Uber, but in drones, something that will carry you, and others, as you can see here. So why this whole thing exploded now? Why in 2016, 17, 15-ish, all the drone hype occurred? This is a classic graph of hype of every technology. 5 years ago, it was the 3D printer. So we have the technology trigger, peak of inflated expectations, trough of disillusionment, slope of enlightenment, and plateau of productivity. There's actually quite a good explanation of how come we end up in 2015, 2016 here. And if you will see at the, on the timeline, 2004 there was a huge leap in the brushless motor technology. 2008, lithium batteries technology. 2009, IMU, International Measuring Unit, Inertial Navigation System, and GPS leap. And 2010, miniaturization of cameras. That led to FPV, flight piloting video, which means that a lot of the drone racing that you see here that you see today is actually those goggles that people put on their hands, on their heads. You have camera that transmit live feed video of the drone to the pilot. and you actually can fly it. On 2013-ish, it became some kind of a consumer product when DJI penetrated the market. 2015, it just became really cheap, and drone racing starts. And that's how we end up on 2016-17 with some kind of hype that you can see today. A lot of drone companies that trying to utilize all those in a way achievement. Can you think of a reason how come we ended up with all those in a way milestones in the timeline? Like what triggered all those things? Mobile phones, exactly. Mobile phones, those tiny pesky things, achieved lithium battery. Batteries now, you can buy batteries, lithium batteries, 275 watt hour per kilo. This is amazing. You could not do that 10 years ago, before, 2008. Same thing for IMU. When you navigate or when you're holding your phone or moving it in certain angles, this is all the IMU. So because you have to produce IMUs in quantities of billions. Same thing for miniature cameras. Those phones killed digital photography. Kodak, that invented digital photography, started to develop their new line of cameras, and everything just died, clipped, because of cell phones. Today, most people have either cell phones or DSLR cameras. No one is actually having digital cameras. And drone racing and the fact that it became some kind of like consumer product just fueled the whole thing, and we ended up where we are. So if we talked about trade-offs, we don't get any free lunches. Everything comes with a price. The payload, the battery, it could be a one-time use. For example, the battery itself is a payload. If I'm sending some kind of UAV to a mission that it will not come back from, I might even use some kind of battery that I don't have to recharge. It will have more energy, but it's not going to be recoverable. The performance itself, the duration, the price. Is price an issue? Maybe it's not. Depends. Availability and service guarantee. Safety. We'll talk about it in a bit. Regulation, and do I have to have runway or not? A really good example of trade-offs is our passenger airplanes. If you kind of think of all the today's aviation world, if it's Boeing or Airbus, I don't know when's the last time that you sat next to the wing, but a lot of the time you can see that during the takeoff and landing, the wings are actually changing their shape. It's called like 2 or 3 element wing. The objective of a passenger airplane is quite simple. Just bring people from point A to point B. But it means that the airplane has to fly really slow when it's taking off and really slow when it's landing down. Because when it's flying at 37,000 feet, it's quite high and it's quite fast. So it means it has to have the ability to fly doing 3 speeds or 2 speeds. Takeoff, landing, let's assume that it's the same speed for the sake of the discussion, and actually flying. That is achievable only by changing the profile of the wing itself. But if you're actually changing the profile of the wing itself, it means that you have here motors, hydraulics, actuators, and this is parasitic weight that you have to carry with you from the source to the objective. It could be replaced by fuel. So everything comes with a trade-off. You don't get any free lunch, any free lunches, never. It always batteries, performance, duration, anything. For example, if I'm going to talk about drones, for example, surveillance drones or reconnaissance or mining, in a way it has to take off and land. It has to get as fast as it can to its place that it has to survey. It has to fly over there, usually relatively slowly, and then comes back. This is quite a challenge because it means that the flight envelope of that specific UAV has to, in a way, perform in 4-3 scenarios that are very different from each other. So if we kind of look at all the UAV markets, I think we can classify it into 3 areas that, in a way, are overlapping. The first one is the hobbyist, is just for fun, like I do on weekends, and I see that some of the other guys are as well. Racing, competitive competitions, photography, agriculture, and this is where we started to see a bit overlap between the two, in a way, trends, topics, hobbyist and commercial. You see a lot of people that are taking pictures just as fun. Sometimes they do it for real estate agencies. Same thing for agriculture. Mining, emergency search and rescue, perimeter defense like airports, this is more of the commercial side. And then we see again overlap between the commercial side and the defense side, because the same system that could be used to defend or assure the safety of passengers in an airport could be used to assure the safety of soldiers in a base. It could be reconnaissance, it could be support or search and rescue under fire. Search and rescue is actually quite complicated because search is one thing, and rescue, it means that you're actually engaging with your platform and helping someone else. It means that you might have to land, you might have to take off in a problematic conditions. And at the end of this, in a way, graph, you can see that there is actually attack. At the bottom side, you might see here a bit of, sorry about that. Trying to find the mouse. From 0 to hero. And this is the footage that was taken from Syria, when they actually used DJI drones in order to attack. They just mounted 40 millimeters bombs on them and just threw it just beneath the drone and hit Humvees. They blacked the GPS, but what happens when you decide to fly without GPS? Or if GPS is blocked, you might use GLONASS, the Russian, the satellite, or Baidu, the Chinese, or the Indian. There is no perfect solution. It's always easier to disrupt and hack than actually protect. So let's talk about regulations and safety. Yeah, that South Park episode was really fun. In a way, the first topic is quite disturbing. And I hope you're not going to fly tomorrow morning or this eve, because we're going to talk about the cost of human life, or in a way, quantification of human life. You have risk, you have harm, and you have hazard. It's two different things, but in a way, the easiest way to explain it is how much does it cost to maintain a human life under certain conditions. For example, in 787-9, how come you have only 8 computers and not 9 and not 10? Because then the cost of the flying ticket will be too high and you won't actually fly. If we're talking about drones, how come we have only 1 electronic spin control per motor? Why don't we have 2? Why don't we have redundancy? Why is our safety is in a way getting compromised? It all comes down to price. And it's, in a way, this is what affects the regulation. There is a certain limit that we, as humans, see, okay, this is reasonable, this is not reasonable, and that's, the, in a way, the line that we can draw and put in front of ourselves and assume that this is good and this is bad. Which leads me to the next slide. You probably saw on the media in the last couple of years, DHL, Amazon, Domino's, whoever delivery companies are doing a lot of hoo-ha on drone delivery. My personal note on it is that I don't think it's going to happen in the next 5 years, maybe a bit more. The reason for that is safety. Safety is the combination of reliability, robustness, redundancy, and whole of other stuff. And it got to do with the previous slide of actually, I am feeling okay if I'm going to drive on the Princess Highway and the drone might crash on my front windshield. I probably will die because of a car accident. So the problem is always the last mile. It's not to get your parcel from the Amazon distributing center to your doorstep or to your city. It's a problem to get it from your post office or something like that to your doorstep. And in my opinion, I don't think that thing will be solvable for the next like 5 years or even more. And most of it because the parcel itself weighs 1 kilo and the drone itself won't weigh a lot. So it means that you don't have a lot of room to put actually safety measured and redundancy and other means to assure safety. So if we're looking at drones as of now, everything was in a way fly-by-wire. I either actually told them what to do using remote controls or joystick or whatever. But The next evolution in those kind of things is sensor fusion. It means that I'm going to get input from ultrasonics, radar, LiDAR, some image processing, and an eye that Mike, yeah, that Michael talked about in the presentation before this one. A really good example is Prometheus. I don't know if you've seen the movie, but in the movie they have some kind of orb or a ball that flies and creates some kind of like laser scan around it. That technology actually exists today. I did it in my own backyard using a LiDAR that you can get from SparkFun or other fruit for $400, and you can create that kind of picture. So in order to create that kind of tunnel or visualization using CloudPoint or something like that, you can actually do it today pretty easily. So if we're looking at a drone now and we gave it some kind of AI and some smarts, the next thing will be probably to give it some autonomous control or even decision making. The main problem today, if I'm flying a drone that is 200-300 kilometers away from me, or even more than that, is the time of flight, is the video and control. Everything that will be more than 200 milliseconds and I actually have to react fast won't be flyable. We have to have a human in the loop. And like Andy said, DJI in a way blackened Iraq and other places, you can just jam it. So there is two incentives to achieve autonomous flying and decision making. One of them is you can not always be the human in the loop. The second thing, you might be blacked out. Those three pictures that you see here is, one of them is a company that does obstacle avoidance. It's called Drone Autonomy. Those two pictures at the bottom, the left one is, do anyone know this company? Yep. Aerobotics. Aerobotics decided that they're going to remove the man from the loop. They're just going to drop a pallet, a container. Their drone is going to fly autonomously from there. There is no going to be a man in the loop, even from like maintenance and battery exchange. The whole thing inside is there is a huge robot in a way, or a couple of robots that are maintaining the robot, change batteries, doing maintenance and everything. So as of now in Perth, there is a mine that you can see. If you go to Perth, you'll see 6 pallets of those that are doing automatic surveys of drones just flying autonomously without even consulting a human being. Another company is Kayaks. They're probably going to launch in Canada first, and they're going to inspect oil pipes, fuel pipes, along probably a couple of thousands of kilometers. And as you can see, those two platforms are quite different. The drone, which stands for, which usually do good in covering small area and hovering, probably can cover a mine, couple of kilometers, and the SkyX could land, it could VTOL, vertical takeoff and landing from a platform between different platforms in hopes of maybe a couple of hundred of kilometers, because it's a flying wing, it's actually an airplane. The last slide, before we can actually start with question, is a video that the US Army released at the beginning of this year. The Swarm, or Skynet. So what we can see here is jet fighters, and they have a payload. The payload themselves is a swarm of drones, couple of tens of drones that will deploy once they're going to be ejected from the back of the airplane. And they have, in a way, an AI, an autonomous artificial intelligence and autonomous behavior once they're being commanded to do certain things. They're not being told how to do it, just do that thing, and they find their path on its own. So this is the deploy, and now they're going to start to do a couple of exercises. For example, get to that point, create a firewall if you want to block something, or just create some kind of formation, etc., etc. It's a cool video. Yeah, that's Skynet in my opinion. And time's up. Questions?